Imagine the red dust of a distant world swirling in eternal silence, a canvas where the winds whisper secrets of forgotten eons, painting shadows across craters that hold the echoes of ancient rivers long dried to dust. We gaze upon this alien vista, a planet scarred by time, where the thin veil of atmosphere clings like a fragile breath against the void. Here, in the hush of cosmic isolation, humanity dares to dream of planting roots in soil that has never known the touch of life. What if the blueprints of our future were etched not in stone, but in the regolith of Mars, blueprints that unfold like petals in the harsh light of a foreign sun? We stand on the precipice, pondering the paradox, a world both barren and brimming with potential, where survival hinges on ingenuity born from the stars. Could it be that in taming this red wilderness, we rediscover the essence of our own resilience, hidden in the heart of a planet that challenges every notion of home? As we delve deeper into this Martian tapestry, the grand scale unfolds before us, a landscape vast and unyielding, where Olympus Mons towers like a sentinel from myth, its slopes rising 21 kilometers into the sky, dwarfing Earth's Everest as if to remind us of our smallness in the cosmic arena. The plains of Elysium stretch endlessly, dotted with volcanic remnants and ancient flood channels that speak of a warmer, wetter past, when water-carved canyons deeper than any on our blue world. Valles Marineris, a rift so immense it could swallow the Grand Canyon whole, scars the equator like a wound from the planet's turbulent youth, a testament to geological forces that shaped this orb over 4 billion years. Yet, amid this desolation, humanity envisions habitats not as mere shelters, but as beacons of life, engineered to withstand the relentless assault of radiation that bathes the surface in invisible fire, doses far exceeding those on Earth, capable of unraveling DNA strands in unprotected flesh. Dust storms, colossal tempests that engulf the globe for months, whip particles at speeds of up to 100 kilometers per hour, obscuring the sun and blanketing everything in a fine, abrasive silt that clogs machinery and erodes hope. Into this arena steps Starship 9, a colossal vessel from SpaceX's lineage, standing over 100 meters tall, its stainless steel frame gleaming like a silver arrow pointed at the heavens, designed to ferry not just explorers, but the very building blocks of civilization across the void. This behemoth, powered by methane-fueled Raptor engines that roar with the fury of controlled explosions, promises to deliver payloads exceeding 100 tons to the Martian surface, a feat that transforms abstract dreams into tangible reality. We picture it descending through the thin air, retro propulsion flames blooming like fiery flowers to soften its landing on regolith that crunches underfoot like brittle snow. From its belly emerge the seeds of self-sufficiency, inflatable domes that expand like lungs drawing breath, their translucent skins woven from advanced polymers, resistant to micrometeorites and thermal extremes, creating pressurized oases where humans can walk without suits, breathing air recycled from the planet's own scant resources. Regolith 3D printing systems, robotic arms that extrude sintered soil into sturdy walls, layer by layer, harnessing the sun's energy via solar panels unfurled like metallic wings, building structures that blend seamlessly with the terrain, fortified against the planet's quakes and ceaseless winds. And hydroponic farms, verdant chambers where water extracted from subsurface ice nurtures crops in nutrient-rich solutions, LED lights mimicking Earth's daylight to coax growth from potatoes, lettuce, and wheat in a cycle that mimics the rhythms of home. These elements weave together into a symphony of survival, where every component interlocks to form colonies that pulse with life, defying the isolation of a world where temperatures plummet to minus 60 degrees Celsius at night, and the gravity, a mere 38% of Earth's, lightens our steps but burdens our bones over time. In this expansive theater, we feel the reverence of pioneers, standing on the shoulders of robotic forebears like Perseverance and Curiosity, rovers that have traversed dusty dunes, sampling soils rich in perched laurets, toxic salts that must be purged before they poison the very gardens we plant. The core phenomenon here is not just habitation, but transformation, turning a hostile frontier into a cradle for humanity's next chapter, where the red dust becomes the foundation of empires, and the stars overhead watch in silent approval. Beneath the visible scars of Mars, hidden signals beckon us, anomalies captured not by the naked eye, but by the vigilant gaze of spectrometers in radar arrays orbiting high above. These instruments, like ethereal scribes, decode the planet's whispers through light curves that dance across data streams, revealing subsurface ice deposits vast enough to fill Lake Superior, locked in polar caps and equatorial veins, their presence betrayed by gamma-ray reflections and thermal emissions that pierce the regolith's veil. We detect the faint hum of radiation belts, invisible torrents of solar particles funneled by the planet's weak magnetic field, a remnant of its dynamo long silenced, leaving the surface exposed to cosmic rays that would sterilize unprotected life in mere months. Anomalies in atmospheric spectra hint at methane plumes, sporadic bursts that could signal geological activity, or, daringly, microbial stirrings in hidden aquifers. Their signatures caught by telescopes like those on the ExoMars Trace Gas Orbiter, painting pictures of a world not entirely dead but slumbering. Dust storms announce themselves through pressure drops and opacity spikes in satellite imagery, their global reach monitored by the Mars Reconnaissance Orbiter's cameras, which map the tempest's paths like cartographers charting tempests on ancient seas. These unseen forces, captured in radio waves bouncing back from buried layers, guide our blueprints, informing the placement of inflatable domes in shielded craters where natural walls blunt the wind's fury, or the calibration of 3D printers to incorporate iron-rich regolith for radiation-absorbing barriers. The intrigue builds as we interpret these signals, each data point a clue, in a grand puzzle where the planet's own emissions become the language we learn to speak, forging habitats that harmonize with Mars' rhythms rather than defy them outright. In this shared voyage across the void, we find a quiet intimacy, a warmth that bridges the cold expanse, reminding us that every blueprint drawn is a testament to our collective heart, beating in unison with the pulse of discovery. Tracing back to the primordial forge, we reconstruct Mars's birth from the swirling nebula that birthed our solar system 4.5 billion years ago, a disk of gas and dust collapsing under gravity's inexorable pull, birthing a molten sphere that cooled into a world of fire and stone. In those early epochs, volcanoes erupted with cataclysmic force, spewing lava that formed vast plains like Tharsis, while impacts from asteroids carved basins like Hellas Planitia, a depression 7 kilometers deep and 2,000 kilometers wide, filled with the detritus of cosmic collisions. Water abundant then, flowed in rivers that etched deltas and filled oceans, perhaps covering a third of the surface, fostering conditions where simple life might have sparked in hydrothermal vents, only to be quenched as the planet's core cooled, its magnetic shield fading, allowing solar winds to strip away the atmosphere like leaves in a gale. From this chaotic cradle emerged the regolith we now harness, a fine powder born of eons of erosion, rich in silicates and oxides that our 3D printers melt and mold into habitats, echoing the planet's own geological artistry. We envision Starship 9's predecessors, like the Viking landers of the 1970s, touching down to sample this ancient soil, their scoops revealing perched laurets formed in the thin air's chemistry. Remnants of a wetter past now turned toxic. Hydroponic systems draw from this legacy, recycling water vapor from the air or melting polar ice, which holds deuterium isotopes hinting at cometary origins, weaving the threads of cosmic history into our farms. Inflatable domes inspired by Earth's tensegrity structures expand in this environment, their materials tested in analog sites like Antarctica's McMurdo dry valleys where temperatures mirror Mars's chill and life clings in microbial mats that parallel what we might cultivate. Philosophically, this origin story stirs a nostalgic reverence, as if we're not colonizing a stranger, but reuniting with a sibling swirl, both born from the same stellar womb. Our technologies a bridge across time's chasm. We reflect on the slow emergence of order from dust, much like the first cells on Earth coalescing in primordial soups, now replicated in Martian greenhouses where algae blooms convert carbon dioxide to oxygen, a cycle that could terraform the planet over centuries, turning red to green in a mythic rebirth. The elemental dance of fire in volcanic forges, dust in endless storms, and time's patient sculpting evokes a rhythmic poetry where each habitat blueprint honors this ancient narrative, embedding human ambition in the very strata of Mars's memory. Science, in its essence, becomes a custodian of these memories, etching the past into data archives that span light years and millennia. We analyze ancient light from Martian meteorites that have journeyed to Earth, like the Allen Hills 84,001 specimen. Its carbonates whispering of warm waters 3 billion years ago, scrutinized under electron microscopes to reveal potential microfossils, debated in journals as relics of life's faint echo. Fossils of atmospheric loss are read in isotopic ratios from Curiosity rover's drills, showing how heavier atoms lingered as lighter ones fled to space, a record preserved in rock layers like pages in a geological tome. Particles from solar wind, trapped in regolith grains, tell of radiation's relentless barrage, their energies measured by alpha particle spectrometers on landers, informing shield designs that layer water-filled bladders within dome walls for protection. Data from missions like MAVEN orbiters map magnetic anomalies, pockets of crustal magnetism that could shelter future colonies, their fields of faint armor against cosmic rays. This act of reading the past, like deciphering hieroglyphs on cosmic papyrus, blends factual precision with a lyrical grace, where each spectrum line is a verse in Mars' epic, guiding our blueprints toward harmony with its hidden truths. The voices of evidence resonate through the scientific chorus, where researchers like those at NASA's Jet Propulsion Laboratory pore over blueprints for Starship integrated habitats, drawing from the Artemis program's lunar analogs. In 2020, the SpaceX's Starship prototypes demonstrated reusable landings, paving the way for Starship 9's enhanced cargo bays, capable of deploying habitats in a single descent, as outlined in peer-reviewed papers from the International Astronautical Congress. Telescopes like the James Webb Space Telescope, though focused on distant worlds, inspire atmospheric models for Mars, while the Perseverance rover's MOXIE experiment, successfully producing oxygen from carbon dioxide in 2021, scales up for hydroponic systems, its timelines marking milestones from Viking's 1976 soil tests to Ingenuity's flights proving aerial scouting for dome sites. Human minds, from Elon Musk's visionary sketches to astrobiologists like Natalie Cabral, weave these threads, their discoveries a respectful nod to the planet's perils, ensuring colonies thrive amid radiation fluxes measured at 700 millisieverts per year, far above Earth's safe limits. Venturing into Mars's invisible landscapes, we uncover subsurface realms where aquifers lie buried under kilometers of permafrost, their waters potentially harboring extremophiles, shielded from surface radiation that penetrates only shallow depths. Dark matter's cosmic web, though universal, parallels the unseen gravitational tugs shaping Martian dunes, while quantum-inspired materials in dome fabrics resist thermal fluctuations from day-night swings of over 100 degrees. Deep time reveals layered basalts from ancient eruptions, their densities contrasting with porous regolith, ideal for printing stable foundations. Metaphors abound. These hidden structures are like the veins beneath skin, pulsing with potential, where radar from the Mars Express orbiter maps ice-rich zones, evoking awe for the planet's concealed architecture that cradles our aspirations. Yet life persists against all odds in such hostility. Much as microbes in Earth's Atacama Desert endure desiccation, their resilience mirrored in Martian analogs where bacteria metabolize perchlorates, inspiring bioengineered strains for hydroponic farms. We ponder human endurance, like astronauts training in isolation chambers, their spirits unbroken by confinement, paralleling the tenacity of life in radiation-blasted zones, a wondrous testament to adaptation's gentle power. Expanding our gaze, refuge worlds like Europa's icy shell conceal oceans teeming with potential, where hydrothermal vents might nurture life, contrasting Mars's dry surface, yet sharing the promise of hydroponic sustenance. Titan's methane lakes and Enceladus geysers offer hydrocarbon riches and water plumes, their extreme chemistries evoking shocking facts. Enceladus ejects material at speeds allowing sampling without landing, broadening our imagination for self-sustaining outposts across the solar system. This awareness sharpens our senses, urging a deeper cosmic vigilance, where the tension of survival on Mars mirrors our own fragile existence, fostering a personal urgency to cherish the delicate balance of worlds. Human scars echo in this narrative, as our Earth's environmental collapses, deforested Amazon basins mirroring Mars's lost waters, stem from unchecked ambition, paralleling how overzealous colonization could deplete Martian resources, turning red soil barren through mining without renewal, a grave resonance of cause and effect. The collapse unfolds viscerally. Dust storms rage, eroding unshielded domes. Radiation seeps through cracks, unraveling genetic codes in hydroponic crops that wither, while 3D printers jam with silt, habitats crumbling like sandcastles in a tide of neglect, a climactic intensity that accelerates toward ruin unless ingenuity prevails. Beneath these perils lurk hidden stakes, where political rivalries between nations like the US and China drive Mars missions. Economic motives fuel resource extraction plans for helium-3 and regolith, and moral dilemmas arise over terraforming's ethics, altering a world's essence for human gain, mirroring historical patterns of colonial exploitation, yet offering global analogies for cooperative progress if wisdom guides. On the balance teeters our future. One path leads to dystopian outposts, isolated and failing under resource wars, radiation-scarred generations dwindling. The other blooms with hopeful collaboration, sustainable domes thriving, hydroponics feeding thriving colonies that expand humanity's reach. Personal responsibility tips the scale, our choices echoing through time, lifting us toward a visionary dawn or sobering twilight. In this reflective closure, the poetic threads weave back, stirring introspection on our shared odyssey, a quiet resonance that lingers like starlight on red dust. What legacy do we etch in the Martian winds? A question that circles back to our opening mystery, reframing the paradox of life in desolation. Connecting to humanity's grand journey, we contemplate legacies of survival, where ethical choices ensure species endure. Metaphors of civilizations rising from dust like ancient Mesopotamia. Lessons from Earth's fragile biosphere teaching us to build not empires but harmonious refuges that outlast the stars.